The Deputy Vice Chancellor Administration, Deputy Vice Chancellor Research, Innovation and Strategic Partnerships, the Registrar, University Librarian, the Provost of the College of Medicine, Dean, Faculty of Technology, Deans of other faculties, the Postgraduate School and of Students, Directors of Institutes and Centers, Heads of Departments, Members of Senate, distinguished guests, ladies and gentlemen, the 408th in the series of University of Ibadan Inaugural Lectures will be delivered by Professor Olatubosun of the Department of Electrical and Electronics Engineering on behalf of the Faculty of Technology. Professor Olatubosun was born on 30th January 1950 to the family of the late Mr. Joseph Adekunle Olatunbosun and Mrs. Dorcas Omoleye Olatunbosun ní Aregbesola. He had his primary school education at Otakpete Methodist Primary School, Ilesha, from 1956 till 1962. And for his secondary education and higher school education, he was at Ilesha Grammar School from 1963 till 1967, and from 1968 to 1969, respectively. The young Mr. Olatubosun, as he was then, had a major setback in life when he lost his mother in an auto accident shortly before his higher school certificate examinations in 1969. It took divine intervention before his life picked up again in January 1972. He attended Yaba College of Technology, Yaba, in Lagos from 1972 to 1974 to pursue an ordinary national diploma OND course in science laboratory technology. Thereafter, in obedience to divine inspiration, he decided to pursue a career in instrumentation and control engineering in 1974 when he was offered admission to Trenchard Polytechnic, United Kingdom. He utilized the Federal Government of Nigeria scholarship to undertake the 4-year sandwich degree program in instrumentation and systems engineering. On completion of his degree in 1978, he was instantly engaged as an instrumentation and control engineer by Webfleet Limited in Redcar, United Kingdom, from where he moved to a research-oriented appointment at Wool Industrial Research Association in Leeds, United Kingdom. He was offered admission at the University of Manchester Institute of Science and Technology, UMIST, which is now part of the Greater University of Manchester, in 1979 to pursue an MSc degree course in instrumentation design and application. He returned to Nigeria to participate in the mandatory 1-year National Youth Service Corps program in the then Department of Engineering Management and Industrial Engineering, Faculty of Technology of this great university. Thereafter, he was appointed as a lecturer grade 2 in the then Department of Electrical Engineering with effect from 1st April 1982. Between 1983 and 1986, he utilized a grant from the Staff Development Fund of this university for his PhD program at the University of Manchester Institute of Science and Technology, UMIST. On his return to Ibadan, he was upgraded as a lecturer 1 and was promoted as senior lecturer with effect from 1st October 1989, reader with effect from 1st October 1995, and professor with effect from 1st October 2002, thus becoming the second professor of electrical and electronics engineering in this university, after Professor Adolphs. Professor Olatunbosun has over 60 publications comprising referate conference proceedings and journal articles in reputable local and international journals. It is noteworthy that Professor Olatunbosun's research work on multi-component flow measurements and imaging, apart from being a pioneering and foundational work to the research work in computed process tomography and 2 international patents in the United Kingdom and United States of America, respectively. At the last count, this work has been cited 51 times, and it has earned referral status in many process computed tomography research work. Moreover, Professor Olatunbosun, as principal investigator, benefited from the MacArthur grant for their project on hybrid renewable energy sources, the success of which qualified him and his co-researchers for an additional grant from the University of Ibadan Research Foundation. Professor Olatunbosun has supervised many students at both the undergraduate and postgraduate levels. Some of his former students are now captains of industries, both nationally and globally, particularly in the oil and gas sector. In academia, some of Professor Olatunbosun's former students are already in the professorial grades in their respective institutions. A deeply committed community person, Professor Olatunbosun has served this university diligently in various capacities, including but not limited to the following: Head of Department of Electronics and Electrical Engineering from October 1989 till February 1992. Then the second coming from October 1995 to September 1997. His third coming, July 2003 to June 2005. Then the fourth coming, that's fourth term, February 2010 to July 2013. And the fifth coming from August 2013 till date. He has been member of Faculty of Technology Industrial Coordination Committee from 1981 to 1982, member of Faculty of Technology Publications Committee 1982 to 1983, 1987 to 1989, then 1995 to 1996, member of Faculty of Technology Postgraduate Committee 1987 till 1989, member Senate Computer Committee 1988 to 1989, 1990 to 1993, member Faculty of Technology Computer Committee, member University of Ibadan Staff School Board of Governors 1990 till 1997, member Governing Council University of Ibadan, first from 1998 to 2002. At the second time, even when he was away to Warri, his friends purchased the form for him and he was elected for his second term, 2003 to 2007. Then chairman University of Ibadan Power Improvement Committee 2014 till date, and he has been a member of the Senate for a very long time. Over the years, it has been very difficult for University of Ibadan to attract many qualified academic staff into our Department of Electrical and Electronics Engineering. But on the other hand, the very few academics in that department have consistently provided the required academic and administrative leadership. On account of the dedication to duty of Professor Adeboye Olatubosun and his colleagues, the Department of Electrical and Electronics Engineering of this university has always earned full accreditation from both the National Universities Commission (NUC) and the Council for the Regulation of Engineering Profession in Nigeria. So we remain eternally grateful to Professor Olatunbosun and his colleagues. Outside this university, Professor Olatubosun has served as a consultant to the following organizations in the area of process automation: the Nigerian National Petroleum Company (NNPC), the National Petroleum Investment and Management Services (NAPIMS), the Port Harcourt Refining Company of Nigeria (PHRC), the Warri Refining and Petrochemical Company of Nigeria (WRPC), the Kaduna Refining and Petrochemical Company of Nigeria (PRPC), the National Fertilizer Company of Nigeria, as well as the Shell Petroleum Development Company (SPDC). He has also served as external examiner to Obafemi Awolowo University, Ile-Ife, the Federal University of Technology, Akure, Federal University of Agriculture, Abeokuta, Ladoke Akintola University of Technology, Ogbomoso, Ekiti State University, Ado-Ekiti, and Yaba College of Technology, Yaba. Professor Olatubosun is happily married to Mrs. Yvonne Joyce Olatunbosun, and the marriage is blessed with children. It's now my pleasure to call on Professor Adeboye Olatunbosun to deliver what I understand is the second inaugural lecture on the Department of Electrical and Electronics Engineering, titled Instrumentation and Control, a Balance of Art and Science. Professor Olatubosun.
The Vice Chancellor of Staff, the Deputy Vice Chancellor of Administration, Deputy Vice Chancellor of Academics, Deputy Vice Chancellor of Research, Innovation, and Strategic Partnership, Registrar, Nigerian, Provost of the Progress School, Deans of other faculties and of students, distinguished ladies and gentlemen. I sincerely appreciate the Dean, Faculty of Technology, University of Ibadan, for nominating and granting me the unique privilege and opportunity to deliver this inaugural lecture on behalf of the Faculty of Technology. Preamble. The Department of Electrical and Electronic Engineering was established in 1981 to run BSc degree program in Electrical and Electronic Engineering. At inception, the department was confronted with issues of office and laboratory spaces, poor staffing, mainly teaching staff, and inadequate laboratory equipment. This was further compounded by the high turnover of the few teaching staff during these formative years. For instance, the first head of the department retired from the services of the university on the 21st January 1993, leaving the department with 2 senior lecturers, 1 lecturer 1 and 1 lecturer 2. The situation was further aggravated when the lecturer 1 resigned to return to his country. Consequently, the leadership and running of the department was left to myself and Dr. Fakulujo since then and not till now. However, we developed innovative approaches for our teaching and laboratory exercises by developing laboratory modules for our laboratory exercises, in addition to the near obsolete equipment donated by the Canadian agency that gave support to the defunct Institute of Science and Applied Technology of this university. They were handed over to us by those who were the leaders of the faculty at that time. It is noteworthy that we as a department have been enjoying full accreditation to date, either by the Nigerian University Commission or the Council of Regulation of Engineering in Nigeria. The departments are grown to add, in addition to our honorary program, 1 professional master program in microprocess and control engineering, and 1 academic master program with 3 options: communication engineering, control and instrumentation engineering, and electrical machines and power systems engineering. This is the first inaugural lecture from the Department of Electrical and Electronic Engineering since the change of name in 1992. However, it is worthy of note that the first and the only inaugural lecture from the Department of Electrical Engineering was given by Professor A.J. Allos in May 1987, titled "For Better or For Worse, the Era of the Electronic Revolution." What is instrumentation and control? How is it relevant to our daily life? From creation, God gave man the assignment of dressing and keeping surroundings. In other words, man and generation have to develop survival strategies by tapping into their inner strength and that of this body for energy for their daily activities. These survival activities have to be based on knowledge that rests solely on measurement and instrumentation, which is the technology of measurement. Therefore, for the survival strategies to be more effective, control is needed. Every one of us practices this every day. You wake up, you walk, you take your strides at precise time, depending on your age and how you are, agile you are. So God has ordained us with that. Invariably, instrumentation and control became the hub of human endeavors, particularly in agriculture, science, engineering, and medicine, to mention a few. This gradually progressed to the development of simple mechanical devices that were used in building the Egyptian pyramids and Roman high-grade aqueducts in those days. Ladies and gentlemen, the inaugural lecture I'm delivering today is titled Instrumentation and Control, a Balance in Art and Science. The major milestone in man's life was when he invented the steam engine, which provided the power that could be easily utilized. This major breakthrough led to devising energy sources. The coming into form of engineering skills made it mandatory that engineering efforts should concentrate on practical application in the utilization of power to the benefit of man. The control of other machines were manual in nature and required regular adjustment and resetting of their parameters in order to improve on levels of control. The knowledge base running the frequent adjustment and resetting of these variables led to having accurate measuring devices with improvement in machine control from manual control to automatic control. This lecture is divided into three broad parts, namely historical perspective of instrumentation and control, its various applications, and my contribution to knowledge over the years. Classification of variables. The information of interest inherent in naturally occurring phenomena is vast. This coupled with the wide application of measuring devices and instrumentation necessitates an efficient method of classification, which will avoid duplication naturally. Similarity occurs in the treatment analysis of various subjects. These similarities are brought by the use of analogies, which is a formidable tool for system modeling. The physical variable which determine the flow of energy in a dynamic system will be classified as a true variable, which will be intrusive or non-intrusive, and a cross variable, which will be evasive. According to Jones in 1972, true variables can be specified and measured at one point in space. Examples are force, momentum, current, and charge. On the other hand, measurements of a cross variable involve 2 points in space, with 1 point as a reference. As a matter of fact, you cannot carry out any measurement without having a reference point. In fact, if any measurement carried without a reference point is null and void. Examples are displacement, velocity, temperature, and voltage. Therefore, basic variable will be classified as shown in 1. All objects in a dynamic system involve a measured or defined relationship between an across variable and a true variable. An electrical capacitor is defined in terms of the relationship between the across variable, which is voltage, and true variable, which is the charge. For most physical systems, there are 2 objects acting as storage elements, i.e. a capacitor and an inductor in an electrical system. We will now address the past, present, and future of instrumentation and control. Instrumentation and control systems are tightly coupled fields of engineering that have evolved over the years, from primitive concepts and devices to modern sophisticated technologies. The diversity in interest of physical quantities to be measured from various interest fields, such as the selection of appropriate sensor based on reliability, accuracy, environmental robustness, reliability, precision, replicability, weight, size, cost, and frequency response are common concern. If improving system efficiency, productivity, stability, safety, and implementation are the prime objectives and goals, instrumentation and control engineering is then the required veritable tool. Time measurements have been identified as some of the earliest instrumentation systems in history since 1500 BC. By 270 BC, some elements of control were found in later versions of clocks. The Industrial Revolution gave further impetus to the application of precision and control to the emerging manufacturing industry, where prime movers were needed in the operations of machines that used to be manually operated. During this period, Colonel Trenchard developed a temperature controller performance around 1620. By the 19th century, extensive ranges of thermostatic devices were developed for feedback control purposes. In 1840, John Gary of British astronomer Royal and Greenwich developed a feedback device for pointing the telescope automatically to compensate for the Earth's rotation for the study of stars. He was able to discover the pitfalls for improved design of the feedback control with the supporting dimension equation analysis. By 1851, he stated the condition for stable operation of the feedback control, which was eventually proven by James Maxwell in 1868. During the first decade of the 20th century, gyroscopes were used in ships, stabilizers, and autopilots. In 1922, Nicholas Vanowski presented a clear analysis of the control involved in position system and for formulating a control law that is now referred to as the proportional, integral, and derivative control. Field adjustment instruments were available by 1940 with PID control. In 1942, J.G. Zegler and L.D. Nichols developed a means for optimal setting of the PI and PID control scheme that later became and world famous Zegler-Nichols tuning rules, which are still in operation till today. The earlier system was a supervisory system in which individual loops were controlled by conventional electrical, pneumatic, or hydraulic controllers, but monitors and optimized by computer. The lessons learned from this system led to the development of direct digital controllers. This was further followed by development of distributed control system that allowed control activities to be carried out in a central control room. They were soon followed by the much cheaper mini computers and microprocessor-based digital controllers and programmable logic controllers, thus making it possible to embed new and emerging control algorithms in software form in a certain controller chip. In recent times, there has been a move from purely mechanical models of system behavior and control algorithms to learning control and knowledge-based control. In learning control, the control system can learn from its environment using artificial intelligence and modify its behavior accordingly. While in knowledge-based control, a range of techniques are applied to reasoning about the situation so as to provide appropriate control actions. Today, control is trying to mimic the way human brain works, and that has led to the development of artificial neural network techniques. Measurement. The act of measurement is for a specific purpose. It is either to detect the state or quantifiable value or predetermined parameters using appropriate instruments. The obtained value could then be used to and operate or for a specific operation. In other words, measurement generally involves using an instrument as a physical means of determining the value of a variable. It serves an extension of human faculties that enable man to determine the value of an unknown quantity, which could not measure. Our old artisans are experts in this area. Holding an object at hand, they can give you an approximate value of that material. The measurement or instrumentation system is supposed to measure, to possess the following attributes. The sensing element. The sensing element is just like our eye, our ear, our nose, our foot. So the formation in most cases is a natural phenomenon, the behavior of which is to be known and quantified. However, the sensing element may or may not be in direct contact with natural phenomena. And if for some of us who can look very far, you can identify an individual at the back just by looking at his face. Examples of sensing elements are thermocouples, where millivolts, EMF depends on temperature, strain gauge, where the resistance change depends on mechanical strain due to applied force, orifice plates, where pressure drops across and obstruction depends on flow rate. We can represent these as shown in figure 1. The signal conditioning element, ability to sense, does not mean you can quantify or give absolute value to it. So there may be need for signal conditioning element, which is referred to as transducer. We say usually the output signal of the primary sensing elements are modified to a form that can be further processed. Examples are shown in table 3. You can see example of sensing elements in table 2. Signal processing element. This element takes the output of the conditioning element and converts it into a form more suitable for presentation. If you develop, for example, everybody you have your phone with you, it's what is displayed is what you are interested in. But the processes of getting that information, you don't even know. I usually tell my students, all these things to you, they are black boxes. You don't know the content, but you need to know the content. So, signal processing is an element that allows us to see the unseen measurement and its value when it's brought to appropriate scale. Development of sensing element. The importance of the sensing element in an instrumentation system cannot be emphasized. It is the eye of the entire system. Suitability, accuracy, precision, and reliability of which must painstakingly be considered. It is the element which are direct or indirect contact with the variable being measured. A typical illustration is given by figure 2, where we have flow in a liquid pipe, heat flow in a material, solid or whatever, and flow of electricity. They represent one and the same thing. The governing equation is as shown in figure 1. And when we look at them critically, we can develop equation for each one of them, as shown in equation 2, 3, 4. If you look at this equation critically, you will see that the across is the Q in the case of liquid, is the heat in the case of heat flow, and I, the current, in the case of current flow. The representation you have there, they are parametric representation, distributed parametric representation. If you can sense any of those values, you'll be able to sense them, and this element that can do that, you can use as a sensing element. In figure 3 is a detailed block diagram representation of an instrumentation system, broken into its parts. As a matter of fact, if you are instrument measurement development, you must follow this circuit. If your desired accuracy is not met, you have to go back all again. In table 4, we have list of mechanical variables that can be measured till today with confidence. Therefore, sensing elements that are often perceived as a black box with input and output terminal is not good enough. One should go further to understand the energy transduction principles and characteristics of the black box. That is when you master what is inside the box before putting it into use. For example, sensing element will be classified as passive sensing element. This group of sensors require a source of energy which can be modulated by a measurement to provide the output signal. The principle of modulation you must know to be able to interpret your result. An example is a capacitor sensor for the measurement of displacement by monitoring the distance between the capacitor plates. Active sensing element. These are sensing elements which draw their energy from the measurement, their measurement of interest. A typical example is when you go to dental clinic and they are taking your body temperature. The nurse will shake the thermometer, put it in your mouth, and walk away. He or she is not being rude. It's giving time for your body, for the thermometer to stabilize with the heat of your body. He takes it up and read it and give it to you. Simple sensing elements, those which have single stroke transduction, e.g. manometers, and you have compound sensing elements. Here you have two sensing elements together to perform a particular function. These are 2 or 3 stages of transduction. An example is a pressure converter that incorporates a pressure to display primary sensing element such as a diaphragm, which you must see in table 2, connected to a secondary system which will be an electromechanical device to give you an electrical signal. We now move to the essence, why instruments and instrumentation system. Dublin in 1966 classified instrumentation system into 3 specific application areas, namely monitoring of processes and operation, control of processes and operation, and experimental engineering analysis. Monitoring of processes and operation. Here, the instrument just gives you an indication of the present, existing, or future value of that measuring. That's all. But when it comes to control of processes and operation, you need a definitive value of the measurement. Here, this is the situation or application where an instrumentation system is a component of an automatic control system. You can see there in figure 4, that is shown. Here, you measure the variable, you compare what it's supposed to be, and you send the error to your controller that provide appropriate correction, we go into your final control element to draw the preset or the system to what it should be. Experimental engineering analysis. In solving the engineering problem, we must consider probable 2 methods, namely theoretical and experimental, and in some cases both, especially if you are to develop system for industrial scientific purposes. Mr. Baton. In our educational system today, this philosophy no longer be followed because we are using customized MATLAB or algorithms that have been dedicated for a particular purpose. Students will use them, they will get results they cannot interpret because they don't have that understanding of combining experimental with theoretical understanding. It's a pity, but that's what we are experiencing now. Obviously, problems on the frontiers of knowledge often require very extensive experimental studies, especially where relevant theories are not yet available. Theory and experiment should be seen as complementing one another. This attitude is not effective and productive. According to Dublin, and I quote, "Whatever the nature of the application, intelligent selection and use of measurement instrumentation depends on a broad knowledge of what is available and how the performance of the equipment will be best described in terms of the job to be done." End of quote. Control system. Engineering is concerned with understanding and control the material and forces of nature for the benefit of mankind. However, the main concern of control engineering is understanding and controlling segments of the environment to provide useful economic product for society. Control engineering is based on the foundation of feedback theory and linear system analysis, and integrates the concept of network theory and communication theory. In other words, every segment of electrical and electronic engineering sees control engineering as a hub of action. The versatility of control engineering cuts across other engineering disciplines into the dynamics of business, medicine, social, and probably political systems. A control system is an intercombination of components or sub-systems informing a system configuration that will provide a desired system behavior. This could be an open or closed loop. A typical example of a closed loop shown in Figure 5. The closed loop control system is so called because a measure of the output information feedback signal is used to compare what that of the desired input information, thereby maintaining a prescribed relationship of the output signal with the input signal by using the difference between the two variables as a means of control. This is achieved using an accurate instrument to measure the output signal, which is negatively fed back to be compared with the input signal. The closed loop feedback system in Figure 4 is referred to as single input and single output. However, in most systems, there are interactions of many variables and the development of the one developed shown in Figure 6, which is called multi-input, multi-output control system. It is so that to decouple them and have effective control. A brief history of automatic control. In 1788, James Watt decided that a man controlling the opening and closing of a steam valve was not the best way of keeping the speed of his steam engines constant. This led to the development of the world governor, which used the lift of rotating balls as a tool monitor to control the development of the valve, supplying the steam to the engine. And show you Figure 7. You can see a spinning wall. As that thing moves up and down, you can see the butterfly valve that controls the flow of steam, thereby controlling the operations of the steam engine. This was the first time that an automatic control system was brought into prominence. The unfortunate fallout of this closed-loop control system was instability. For example, haunting of steam engines and shift steering, thus highlighting the need for a mathematical analytical tool to resolve the problem and make the system stable. Maxwell in 1868 developed the first analytical tool for minimizing instability in a control system. Most lasting contributions on problems of stability in general were made by Hans in 1875, Ralph 1884, Lippanov 1892, along with the essential works of mathematicians as Laplace 1749 to 1827, Fourier 1758 to 1830, and Cauchy 1789 to 1857. Students of electrical engineering now know the reason why you need to pay attention to these courses that you audit in the mathematics department. The increase in the use of automatic control were very slow until the development of electronics. Although electronic circuits were being developed specifically for the telephone system, the amplifier developed suffered from instability and made voice communication over a distance of miles in practical. However, In 1927, a young man named Black in America, working for Bell Laboratories of American Telegraph and Telephone, AT&T, were driving across the Hudson River on Tuesday morning of 7 August 1927, suddenly had a flash in his mind on the concept of a negative feedback amplifier. In his response, Black said, and I quote, "For more than 50 years, I pondered how and why the idea came, and I can't say any more today than I could that morning. All I know is that after several years of hard work on the problem, I suddenly realized that if I feed the amplifier back to the input in reverse rates and kept the reverse from oscillating, singing as we call it then, I will have exactly what I wanted, a means of cancelling out the distortion in output." Intuitive knowledge opened the gateway to negative feedback. The negative feedback measure to sustain system stability. Isn't that amazing? Could this be called revelational knowledge? With the development of electronics, the application and theoretical understanding of closed-loop control increased rapidly using the feedback concept. Among the most significant step was that of Inaugural in 1932, and then you have the effort of Hertz in 1934. However, there is a deep down. The frequency was being approached in the European countries, but the present day Russia sticks to the differential equations approach. Frequency domain techniques continue to dominate the field of control following World War II, with the increase of use of the Laplace transform and the complex frequency plane. In the 1980s, the use of digital computers for control became routine. The space age impacts significantly on highly accurate control systems for missiles and space probes. The necessity to minimize the weight of satellites and to control them very accurately has found the important field of optimal control. A natural stage in the evolutionary process of modern engineering is design is encompassed in controlling the principle of the closed-loop control. Systems are encountered with varying degrees of complexity, where one or more parameters are to be controlled with precision. Typical examples are the control of temperature or pressure in the chemical process, position of velocity in the mechanical system, output voltage from the electrical generator, price rate change in economic inflation dynamics, epidemic disease control in a community. Although the examples are diverse in physical nature, they are similar in obscure ways. For example, they are prone to vary as a result of external or internal disturbances. It is highly probable the parameter being controlled requires its value to be updated continuously in order to meet some requirements. In other words, in all these fields, a closed-loop block diagram can be used to represent this system, and the techniques of control can be used to solve that problem. Hence, there should be no barriers in discipline when instrumentation and control is concerned. Some examples of application of feedback control: aircraft control system, missiles launching and guidance system. In figure 8, we have the block diagram for a missile launching and guidance system. The plane is sighted by a rotating radar antenna, which locks in and tracks the target. Its very position and velocity are transmitted to a ground launching computer to compose the required firing angles in terms of launching command signal. The signal is amplified to drive the launcher. The launcher antenna position is fed back to the launcher computer, and the missile is triggered the moment the error between the launch command signal and missile firing angle is zero. The fire missile instantly enters the laser beam. We provide a guidance signal to the control system within the missile and automatically adjust the control space of the missile only in on the target. Of course, the plane will have to disappear. Feedback control investment. Information gathered from patients and the processes of decision making. The critical medicine and healthcare delivery depends essentially on the effective interpretation of gathered information and data obtained by measurement practice. This activity fits perfectly into the block diagram representation of an instrumentation and control system. Therefore, the adaptive instrumentation and control system in critical medicine can be as shown in figure 4. In some cases, however, anticipatory control action may be taken feed forward based on the current status of health of the patient and the possibility of knowledge over the years by the clinician, thereby embedding a feed-forward path to the area block diagram. This control system paradigm is is useful in clarifying the manner in which a computer model can be meshed into the existing patient care process and show the effect. So in medical fields, control theory has a wide application, such as temperature regulation, neurological, respiratory, and cardiovascular control. An example is the automatic anesthetic control, where the amount of anesthetic of the patient undergoing operation can be measured from encephalograms. The application of the control procedure can indeed automate the practice of anesthesia in hospitals. Application of control theory in non-engineering fields. The universality of the principle of control in the present state of art provides discussion into fields like economics, sociology, and science-related disciplines. This universality is as a result of a feedback concept of control. For example, a simple block diagram can be used to model the economic inflation dynamics as shown in figure 11. I hope my friends in economic are listening. All you need to do is to use appropriate algorithm and use it to handle your field collected data, and then you can be able to make projections and make some calculations. Mr. Vice Chairman, now I go to overview of my research and development efforts. I must admit that the high proportion of my research and development work has been on the instrumentation system. My first attempt is trying to prove a theory and start heat flow through a flat surface. Temperature measurement is an important parameter in the determination of rate of heat flow into or out of any surface that is subjected to temperature gradient, i.e. heat exchangers, fractionation columns, reaction vessels, etc. However, the relationship between the rate of heat flow and any measured temperature difference is not linear because of the presumed turbulence nature of heat distribution along the flat surface. Despite this turbulence, heat distribution at the flat surface, a nominal bounding layer of fluid near a heated surface could occur if the full flow velocity is known. Mind you, sir, I said could occur, implying that heat distribution in the region is mainly by natural convection, the so-called Bruyas effect. In 1980, Olatubosun validated this assumption by developing a temperature measurement system using two identical miniature bead thermistors, as shown in figure 12. For 3 different inputs to the heated surface, it was established that turbulence did occur at a distance less than 1 millimeter to the surface wall from the heated plate due to closeness of the sensor to the surface causing vortices. This was followed by minor flow from about 1.5 millimeter to 8.0 millimeter from the surface, as shown in figures 13 and 14. The experimental rig, actually the photograph is there, and the results are shown in figures 14, 15, and 16. My efforts into multi-component flow measurement and imaging. In January 1983, when I returned to the University of Manchester Institute of Science and Technology for my PhD program, led Professor M.S. Beck, a renowned professor of instrumentation engineering, with a special research interest in non-intrusive measurement of fluid flow in conveyor pipe using the capacitance technique, asked me to join his team, but to concentrate on developing fluid flow density measurement using a vibrating tube intruding to the fluid flow. I was not happy with the topic because I knew that intruding into the flow disrupts the existing flow patterns of each component of the fluid medium. Most multi-component flow experiences spatial and temporal variation in the distribution of their components over the pipe portion. Therefore, intruding into the flow should undermine the study of the behavior of the fluid flow in the component pipe by modifying their spatial and temporal variation due to their moving internal interfaces. During my literature review, I came across an article by Abuwafo and Kendo in 1980 on the measure of component ratio in multi-phase system using X-ray attenuation. This was not altogether new because in 1973, Humphrey developed the computerized transverse CT alga scanning tomography system, the present-day CT scanner. This was for an auto-peak transmission of the X and gamma rays through the material being investigated. Their implications were cumbersome and very expensive. I think those in the College of Medicine can testify to this. However, I find the complete scattering approach very attractive. As I ruminated on this technique over a period, I heard the voice say, can't you generate your complete scatter photon externally instead of internally using low atomic number solid material? I knew where the voice came from, the Almighty God. I instantly obeyed and did a schematic of the million arrangement. When I discussed with my supervisor and other members of the team, my idea was laughed at as an unproven theory, but I was not discouraged. It's a bunch of things. Half-heartedly, my supervisor gave me the permission to try my luck at the University of Geological Protection Services of the University of Manchester. They too were not that convinced, but allowed me to carry the primary investigation. The set-off for the primary investigation showed it was 7, using 125. The primary results show that the attenuation of monoenergetic gamma rays through a material is related to the mass attenuation coefficient of the constituent part of the fluid mixture. Therefore, when directed, completely scattered gamma photons from different scattering angles produces multi-monoenergetic photons. Please mark the word monoenergetic, and that could instantly traverse the material through their individual angular paths. The photograph of the new measurement system is as shown in Figure 18. One could easily observe from Figure 18. You can see there in Figure 19 the two sensors, the two radioactive sources. This time I used C137. With the angle, you can see the two detectors at the bottom. So the magnetic gamma rays that is produced traverses those and dividing the material into natural pixels. Obtaining that information from the multi-channel analyzer, I applied hybrid imaging reconstruction algorithm to produce the distribution of the components within the cross-section areas as shown in Figure 20 to 32. You can see there is a blip at the middle. You can see there without representation on the top of the port in 3 dimensions in Figure 32. Then the photograph, we use another pattern. That's the photograph. When we use 12 pixels, that's what we get. When we move on the number of pixels, you can get exactly the same. This, apart from the constraint we have here, because I learned earlier that Nigeria hasn't got capacity to store high energy radioactive material. That was being known when I came back in 1987, visited a radiological protection center, and I was amazed that they cannot handle radioactive material in excess of 5 million curies. Mr. Prof, I'm happy to inform you that this one was a major landmark in the history of non-intrusive multiple measurement. It is a foundation pioneer work with process tomography that was protected in both the United Kingdom and the United States of America. At the last count, 3 months ago, a total of 51 citations were registered, and it has become an internationally acclaimed major contribution to the world in the area of process tomography and imaging. On completion of my PhD in 1986, this research work and a research grant for further investigation and exploitation by the Science and Engineering Research Council of Great Britain. Fortunately, or unfortunately, I had to return to the University of Ireland and sponsor my PhD work without utilizing the grant. On return to Nigeria in 1987, as already stated in my preamble, I have to make do with available facilities. I will now highlight a few of my success stories that I supervised. In 1991, Olatubosun developed an automatic tape-less stochastic dispensing and counting rotating machine using an optical sensor and associated electronics circuitry as shown in Figure 27 to replace the unhygienic manual counting and dispensing of tape-less and counting in some of our medicine stores in Nigeria. You can see the device. It can automate that doesn't need. I can't go into details because of time. During the same time, the same period, academic another person developed an optical voting device for the medical counting of goods. The device has a non-volatile line for storage of the total count and each polling goods with security laws that will not be tampered with and shown in Figure 29 evidence. This was in the days of Option A for open ballot election. The success story was aired by the media namely Nigerian television and the Nigerian TV. I was encouraged by this and sent the full design of the equipment by registered post to the Director General in charge of the electoral process at that time. However, to my dismay, the registered document, although received, was returned unopened. The only solace I had when Professor Olatunbosun, a former dean of the faculty, came to congratulate me. In 1998, Okunaya, Ilebare, Atagan, and Pipelu, under my supervision, designed and built the flow rig for research on multi-complete flow measurement and calibration of process industry measurement instruments. As at that time, NNPC has no, I'm too sure the state has no means of monitoring the volume of crude that we export. They use the meters of the company. They don't have. The rig cost about 70,000 naira to build, which was contributed by the students. It was money well spent by the students because they were instantly employed on completion of their studies, 2 of them by Shell Petroleum Development Company and the other 2 by Stone Company. Unfortunately, every effort made for further deployment of the rig by the federal government failed, and the rig was eventually dismantled and critical material stolen by staff of the contractor responsible for converting the annex block for residential use. In 1997, Odekide investigated the use of locally fabricated capacitor plates to measure fluid flow in a concrete pipe in contacting, in other words, inside the pipe, and not contacting outside the pipe modes. In the case of the contacting mode, we discovered discontinuity in the observed capacitor changes with volumetric flow rate, implying presence of dead zone, in other words, with electrostatic field at the center of the pipe, as shown in figure 30. This observation was never reported in literature, maybe to protect the non-intrusiveness of the capacitor technique being intentionally promoted vigorously at that time. With this discovery, we introduced a grounded top plate at the center of the pipe, and lo and behold, the problem was solved, and the results are shown in figure 32 to 33. This investigation was continued in 1990 under my supervision by Idowu and Oshideko. Idowu on flow measurement and Oshideko on flow level measurement. Idowu studied the effect of different configurations of the 10 electrodes. She investigated 4 different configurations as shown in figure 34. In our work, a very respected professor in our department of physics, we contacted him and said, we want to develop a capacitor measuring technique. Lo and below, the result was rather elusive. He said, what is it to study in capacitor? I said, sir, if you are able to develop this device and it's commercialized, you become a millionaire in any currency of your choice. The experimental result obtained by Idowu was a notable improvement in Odekide's work. Idowu was able to establish a linear relationship between volumetric flow rates and capacitor change. The same linear relationship was established by Oshideko for liquid level measurement. We have locally designed, constructed, and tested a non-intrusive liquid level and volumetric flow measurement device with a better consistency and accuracy with the conventional intrusive devices in the process industry. But their commercialization is non-existent. With the confidence we have built up since 1997, we move on to capacitor tomography based on established configuration. In 2007, I daily Jambo, under my supervision, developed an electrical capacitor tomography system for 2 component fluid flow as shown in 36A, B, C. They actually build the device. This is not a simulation. And figure C showed the discharging and charging of those capacitors. It's a real system. 3 electrode pairs were designed and constructed, each pair on individual variable and mounted outside the flow pipe as shown in figure 36. The charging and discharging is shown in figure 36C. The uniqueness of this work was the use of the electrostatic field sensitivity distribution, sensitivity map, for all the electrode pairs as the tomographic pixel instead of the conventional rectangular pixel superimposed on the electrostatic field distribution and shown in figure 37. The sensitivity map has superimposed on them normalized major capacitance to obtain the tomographic images of the objects through component flow using static phantoms. Using linear back projection image construction techniques, we were able to produce effective image of the phantoms and shown in figure 38 to 39. In 1999, Olatubosun, I won't say Lucas, and Colonel Professor Lucas developed an electrical conductive type meter for determining moisture content of wood. The meter weighs only 2 kilograms and uses 9-volt battery as power source. We use it to measure the moisture content of apparel. Terminania, Supaba, Anure, Alivisia, Sigia, and Ubechi, Chipolochiton, Zolo. Baba, am I right in my pronouncement? Thank you, sir. It was found that the electrical conductivities in these two species vary reasonably linearly, with their moisture content in the range of 10% wet to 25% dry basis. This is the moisture rate at which virtually all commercial processing wood tend to operate. The fabricated meter is accurate to within plus or minus 2% when its results were compared with standard oven dry method of moisture content determination. This was found to be of better performance than the important ones at that time, having a range of only 10% wet and 20% dry, with indeterminate accuracy range. The developed system has shown figures 40 and 41, and you have the results for various selector of woods, figure 42, 43, 44, 45, 6, and 7. In the course of my visit to a national oil and gas refinery company and some of our electrical generation plants in the Niger Delta area, I was shocked by the fact that they were only carrying out breakdown maintenance activities, a good recipe for equipment long-term downtime, and low productivity at high production cost. With this experience, we carried out an investigation on the production efficiency of the decision column of Port Harcourt Refinery Company using their in-house data. Our investigation showed clearly at figure 48 that there was excessive use of reflux flow to meet product specification with the PID controller embedded in the distribution control system. Our ANF control-based controller that we use for investigation produced a better result, and we could determine from the result. The result shows an increase of energy consumption and reduction in the destination column production capacity. Olatubosun 20 years. As a senior training consultant for the Shell Intensive Training Program, I took an interest in some of the upstream oil and gas production actions, especially in oil and gas well and reservoir management. During this interaction, I noticed they needed more process control and management to interactively aggregate the potential of this core petroleum engineering discipline for optimal management of the oil and gas wells and reservoir. For example, reservoir fluid properties are very important in reservoir engineering computation, such as material balance calculation, well test analysis, reserve estimates, reserve performance and intervention, production design and operation, formation evaluation and reserve simulation. Inevitably, knowledge of the PVT, that is pressure, volume, temperature properties, is traditionally required for various types of petroleum calculation, such as determination of hydrocarbon flow properties and reservoir volumetric estimates. Traditionally, PV data has been collected and correlated over the years for different types of hydrocarbon systems. In most cases, the linear and nonlinear multiple regression in graphical techniques are used in obtaining this correlation. This periodic exercise is tedious, laborious, and time-consuming. In 2012, we developed an artificial neural network-based algorithm for the determination separately of gas-oil ratio and water-oil ratio of known oil wells in the Niger Delta area of Nigeria. Our result, as shown in figure 49 and 50, produced better results within a short time, devoid of the usual rigors and complexity of the methods in use as at that time. Now, in the case of electrical power systems, the observed breakdown maintenance practices at some of our electrical power engineering plants and refineries inhibit maintenance activities, record keeping and reporting of actions taken, to restore the plants and device to active use. In order to ameliorate these lapses, we developed an expert system-based equipment diagnosis tool in 2004 as an aid for effective monitoring of states of industrial equipment and devices that is knowledge-based. It comprises of computerized maintenance software using a top-down system concept. The software package allows for the storage, processing, updating, and retrieving of equipment maintenance data from a database file and generates reports for quick troubleshooting, control, and management. The system is also capable of improving and enlarging its knowledge base by daily routine learning exercises when in operation. This enables an increase in equipment availability and minimal maintenance costs and time. Olatubosun and Inaugural in 2004. The model of our system is shown in Figure 51. The introduction of the global system for mobile communication (GSM) in Nigeria brought about arbitrary siting and installation of base stations for data voice transmission from one point to another. This entails high data switching by the transmitters, causing the injection of soft electromagnetic radiation into the immediate environment from a particular base station, which result into slow building up of background radiation into the vicinity. Mr. Bashir, sir. This work was of interest to me before close to where my mechanic was. We just learned that the landlord just died of a sudden. And the thing was that after being given 750,000 naira, he allowed the base station to be placed right behind his bedroom. So if something that necessitates an investigation. In 2010, we carried out an investigation on the probable accumulation of this radiation in selected areas of the body and found out that the build of this radiation over a period of time would be harmful to the people living in the area after a long period of time, as shown in Figure 52 and 53. You can see you are living very close to those figures. The intensity of radiation is very high. And if you are in that environment for a long period of time and you are absorbing this soft radiation, anything can happen. Same thing with your hand phone. It is called heart phone, not pocket phone. It is called heart phone, not breast pocket or whatever phone. You are told when the level of your body is low, the radiation coming out of it is very, very high and can be curious. You are warned, take note. The application of distribution and control in the practice of medicine is another research area of interest to me. This is driven by the near absence of deserved medical care for rural dwellers due to the acute shortage of personnel and facilities. Nigeria, as of today, is not sufficiently endowed to provide the deserved facilities to these dwellers, but such facilities could be extended to them remotely via telemedicine. Telemedicine is an emerging field where internet connectivity has become an effective communication bridge between engineering and medicine. Telemedicine allows diagnostic data collected from one location to be transferred to a remote host. This could be used to transfer diagnostic data from cottage hospitals, health centers remotely to teaching or general hospitals for critical and in-depth examination by experienced doctors and surgeons who can then decide on action to be taken. With this in mind, we have developed some diagnostic instrumentation system for blood pressure to body temperature measurement, gauge measurement, electrocardiogram, and X-ray digitization. This electronic data could be transmitted to host station in a remote location for interpretation, thus extending medical facilities and experiences of medical staff to patients in rural areas. These are clearly shown in Figure 54 to 57. The basic design implementation are shown. The first one is that of the gate. You can see the layout of the components and the shoe that is used. At this point, I have to thank my colleague in Jaja and College of Medicine for allowing my students to interact with them. You have plots there of base for various individuals, and from there, it can be done instead of a physiotherapist looking at you as walking up and down and show whether you are leaning to the left or right. Figure 58 shows the system blood pressure and temperature measurement system and the signal transmitted to remote host. Here we actually transmit the information to a remote host. We measure the blood pressure using infrared devices from your finger, as shown in Figure 59. And the graph of our photo electromatogram and portrait is shown. These compare favorably well with existing one in the market and in use in most of our hospitals. Again, we are able to digitize X-rays for transfer to remote location. Our digitized value compare favorably with the continuous X-ray fields. You can see there in figure 62. In 2012, I took an interest in the development of renewable energy sources for provision of electric power for people living in rural areas that could not access centrally provided electric power, thereby denying them the ability to further enhance their endowed potentials. I am sincerely grateful for the grant given to us by MacArthur Foundation to pursue this laudable goal. The grant enabled us to develop a solar energy and micro hydropower system with combined power output of 15 kilowatts. I'll show you figure 64 to 68. We actually fabricate this work. I have to commend the efforts of Mr. Tolu Ajuape, who designed the turbine and made sure it was fabricated for its MSC goal. The initial seven-story airport in gaining an initial grant of 7.5 million from the University of Ibadan Research Foundation. The development is ongoing, and with time scaling the total power provision to 50 kilowatts. We are now adding energy from biomass, energy from hydrokinetic, and from hydraulic plant. In 2015 to 2016, we did a study of some critical equipment of the field catalytic cracking unit, FCCU, of one of our national refining companies. Typical result of our investigation are shown in figure 70 and 71. It is very glaring, if you're able to see that figure, that from about 2011, the reliability indices of this critical equipment was below 50%, necessitating the need for either complete overhaul or total replacement of the equipment. The electric performances of our refining plants can be easily deduced from this abysmal reliability indices. In 2017, Lawal, one of my PhD students, successfully defended his thesis on the development of heteroclical and decentralized architecture for multi-sensor control system. This is a major departure from the existing electrical and distributed architecture system currently in use in our manufacturing and processing industry. It is more reliable and have better performance when compared with the existing system as shown in figure 72. You can see the result there that at a very small change, the existing one just deviates, whereas you are able to track up to about 300 seconds. By that time, if you are launching an object into the space, you are already there. Figure 72, 73 shows the circuit arrangement, the implementation, and then the post-flight data analysis, and how it is embedded in the avionic bay at the Center for Space Transport and Propulsion. Okay, Mr. Vice Chancellor, sir. I don't know whether this screen can be brought out for you to see, because I know the LDR can see. Sir, if you can be able to see the launching of this device. I have a friend that tries to speak Yoruba. You say, oh my soul. Mr. Bashir, sir, please permit me to give my closing remarks. We could observe that this lecture is based on providing what we need from what we have, in line with the earlier elucidated survival strategies. If we agree with this, it means we must, as a nation, stop our total dependency on survival strategies from other nations and start developing our own. Borrowed technology can only exist for a period of becoming obsolete and unreliable unless it is domesticated as a sector. However, hope is not lost. We can retrace our steps by doing the following. 1. Set up technically competent committee to investigate and determine the root cause of the failures of existing infrastructures, i.e. railways, refineries, pulp and paper industries, steel industries, power generating plants, textile industries, automobile industries, and the National Financial Company of Nigeria, NACO. These are very good and laudable projects at the section, but they are now ghosts of their own self. 2. Set up another technical committee to independently consider the report of the first committee and articulate an effective roadmap for industrialization of Nigerian resources. This committee should be able to determine the merits and demerits of centralization of infrastructure stroke industrial development, the vow of what is in need for me. I will go beyond that, but what is in need for me is what is undermining our development. Energy program. The census regulating and national inadequate energy power generation, transmission and distribution has hindered industrial development and consequentially economic growth of the country. It requires a total overhaul and a holistic review. Over the years, a colossal amount of money was allocated to this sector of the economy without any improvement. There is another need to go back to the drawing board and sincerely address the following questions. What is the maximum power carrying capacity of our transmission system? What is the initial design capacity of each power of our generating plant, hydro and gas? Is a centrally based power transmission system sustainable, reliable, and capable of transmitting power to remote locations conveniently at a low and affordable cost? Do we have a robust national template for blending renewable energy sources to our existing plants? Comment. There are a lot of difference between design capacity, install capacity, and operational capacity. Government should be able to inform us which capacity they are referring to at any given time. If we are an operational capacity, we should urgently move towards increasing the capacity of the existing plants to the design capacity, where adequate provision in terms of civil walls are being provided from inception. For example, Kainji and other hydropower plants should be upgraded to their respective design capacity. The same situation should apply to our gas gathering plants. It is usual practice that an industrial plant should be close to the source of needed raw materials. If that is the case, why can't government build gas-fired power plants close to the gas gathering plants? This is the only sensible approach that should be able to kill two birds with one stone, that should lead to a reduction in gas partner vandalization, provision of power to the local community, and easy evacuation of power to their areas in need. We must move as a matter of urgency from a centrally based system for power transmission, which is currently weak and inefficient, to a power distributed based power transmission system. This will forestall our insistent national power system collapse until we have 6 up to date now from the beginning of the year, and vulnerability to vandalization. The ongoing renewable energy projects need effective and sustainable coordination and implementation. Irregular and unreliable power system has caused a good number of industries to close down and move to neighboring countries. We cannot turn a blind hand to this if our economy is to grow. Government should address this urgently. The national gas gathering project should be resuscitated. It is a shame that we are still flaring gas in 2017 when the initial time to stop it was 2008. Admittedly, the initial project by NNPC was a colossal failure. NNPC should work for the cause of failure and carry out appropriate remediation. The Nigerian gas company can do more in this area than what they are presently doing. Considering now at home, considering past privileges and opportunities in University of Ibadan as hand, we should by now be self-reliant to some extent. I strongly appeal to the university authorities to urgently revisit the vision of Professor S.O. Olayide, who deemed it fit for the university to have a science park for the commercialization of our research outputs. Mr. Vice President. Mr. Vice President, at the beginning of this lecture, I mentioned the previous state of my economy. I ask that we appeal to you to please consider the plight of the department in terms of the responsible teaching position, provision of office and laboratory spaces, and teaching and research equipment. In the same manner, we shall be very grateful for telecommunication laboratory presently abandoned by the contractor in the visited and awarded to another contractor for completion. The present state of our tertiary education in the broad discipline of electrical and electronic engineering is a matter of serious concern. The rapid technological development in this field has created a wide gap between what is taught in our various tertiary institutions and the global current trends in the field. This gap should be addressed as soon as possible so that our graduates will be relevant in the marketplace. The national education policy for each level of our education system is signed this urgent review. If we are not to be left behind in the global scheme of things. Acknowledgement. First and foremost, I have to give honor, glory, and thanks to the Almighty God, the author and giver of life, to make this day a reality in my life. Surely without you, I will not have been what I am today. The Olatubosun and Trenchard dynasty, from where I came, I deeply appreciate your love and support over the years. But I will not forget to give special tribute to my beloved father and mother, late Mr. Joseph Olatunbosun and Mrs. Douglas Olatubosun, for giving me a good beginning in life, despite their legal resources. You led me early in life, but you did let imprints of godly virtue, honesty, integrity, and hard work in my hand. You gave your best, but could not withhold the result. I deeply appreciate the period. My special gratitude and thanks to my uncle and dad, the present patriarch of Olatubosun family, Pastor Professor David Adejubi Olatubosun. Can you please rise up for your recognition, sir? Both of you led me early in life, but you did let me peace of godly virtue, honesty, integrity, and hard work in my heart. You gave your best, but could not withhold the result. I deeply appreciate the period. My special gratitude and thanks to my uncle and dad, the present patriarch of Olatubosun family, Pastor Professor David Adejubi Olatubosun. Can you please rise up for your recognition, sir? Well, the value may be different. He gave his own lecture in this university in 1983. You brought me here and waited for this day. You are witness. Thank you, Daddy. I hope I have not disappointed you. To my in-laws, the Mafales and the entire family, I am very grateful for giving me your precious daughter in marriage without knowing what the future entails. The journey of many years in the first step. In this journey, my path crossed others, and I thank God for the opportunities. I am seizing the opportunity to thank my teachers for giving me their best in terms of education, of teaching and moral building, right from primary school to my university education. The discipline is still in us. They are here. Reverend Taiwo Adewale Senior, can you rise up for recognition? The discipline is still in us by late Colonel J. Akiyemi, who are usually called the Akiyemi in all of those. Our principal in the early years in secondary school education and the Nation Grammar School can never be forgotten. I'm very grateful to my PhD supervisor, Professor Maurice S. Beck, for condescending to my request that made me what I am today. May your soul rest in perfect peace. I sincerely appreciate the past and present members of staff of the University of Ibadan and of Faculty of Technology who made definitive contribution to my life. I cannot fail to acknowledge the impact of Professor Dr. Philip, the former Dean of the Faculty of Social Sciences and Chairman Committee of Deans, who single-handedly approved a staff development grant for me in 1983 for my PhD program at the University of Manchester Institute of Science and Technology. I am very grateful for the encouragement and support of former deans of the faculty, namely Pastor Professor F.O. Abuaba, Professor P. Oluwande, Professor G. K. Falade, Professor O. Bamiro, Professor J. C. Baker, Professor O. Ofi, Professor B. Alabi, and late Professor O. Omole, a childhood friend and classmate. Professor A. Oluleye, Professor O. H. Sowaba, I appreciate you all, sir. To the incumbent dean, Professor A. Aja, ably represented by Professor Ishenwa. I say thank you and God bless you. The past and present members of staff of the Department of Electrical and Electronic Engineering, I thank you for your support and the cordial relations you have had over the years. What can I say of other members of staff of Faculty of Technology, local and centrally deployed over the years, for your help and support? I am very grateful. I join my single for special appreciation, my bosom friend, Professor Mustiu Adomiwa Onilude, a good confidant and a pillar of support, who took it upon himself to read and critique this lecture. I am very grateful to you for your help and support. I deeply appreciate the spiritual fellowship my family and I are with the University of Ibadan Christian Family Fellowship under the leadership of Professor F. Agwaba, a true family fellowship where love and sincerity of faith life. He gave us the opportunity to drink from the spiritual west of Professor Mrs. Grace Lunge, Professor O.O. and Mrs. Katie Olatubosun and also to the 1967 set of Trenchard Grammar School. I thank you for being good friends and companions. To my father, pastors, and spiritual brethren in the Lord in Nigeria and Inaugural, I say thank you. The leadership of Friend of Blessed Christian Ministry, I deeply appreciate you and express my heartfelt gratitude. I hereby express my appreciation to the past and present leadership and their membership of Pastor Ibadan, Brian. I thank my community members. You know yourself. You are interesting and never boring bunch. I appreciate every one of you. To my past and present students, I shall give a big thank you for your contribution. The inner committee members, namely Professor M. Oyewola, Dr. Agide, Mrs. Sarah Akitola, MS Christiana Polo, Mr. Kode Oloriwe, who singularly handled the work process of this material. I say big thank you for your dedication, support, and commitment. The Almighty God will surely richly reward you. My darling wife, of inestimable value, Mrs. Yvonne Jeff, you can start out to be recognized. I am so forward to express my deep appreciation and love to you. You will remain unwavering despite all challenges and difficulties in keeping the whole front well and healthy during my numerous travels in and out of Ibadan. You contributed immensely to make it this day. I joyously dedicate this lecture. My boys, Joseph, Philip, and Jonathan, and my daughter Ubani, you are my joy and delight. I will always appreciate and appreciate you for the rest of my days. Apart from the King of Glory, the Almighty God, my Lord and Savior Jesus, you have made life worth living. I thank you all. Mr. Vice Chancellor, sir, distinguished ladies and gentlemen, I thank you for listening, and the Almighty God, the King of Glory, the unchangeable changer, bless you all for listening. But remember, it is precept upon precept, line upon line, line upon line, here a little, there a little. Thank you.